So today we will discuss uh, basic information regarding retaining walls, and that means what is basically a retaining wall, what are the various type of forces, why we have to design it, and on for what we have to design it basically. So retaining wall, uh, even earlier in other subject we discussed retaining wall. So if you see the right side picture, so you will be seeing there is a wall which is retaining some backfill, maybe some different type of material. It may be aggregate, it may be sand, or any type of mountainous land, etc. So basically, this is a retaining wall. So now retaining wall itself means, now when we have to define the retaining wall, that means what is the definition? So retaining walls are used to, basically they are walls which are used to retain earth or any other material in vertical or nearly vertical position at a location where there are changes in the ground level. So that means where ground level is changing, so there may be backfill, and we have to support that backfill. Retaining wall you may find in mountainous region near the roads, that means road network, or near about a river area. Everywhere you will find the retaining wall. So what are the various important points which we will discuss? Retaining wall prevent the retained earth from sliding. Now this is the where my mouse cursor is moving. So this is the mass fill, backfill, and this is the retaining wall. So it is clearly visible. The retaining wall prevent the retained earth from sliding. If the retaining wall is not getting filled, then this material will be successfully retained. Now, earth retained by retaining wall. Now, what will happen to the retaining wall when it retain the material behind it? So that material, that earth or retained material will exert lateral pressure on the wall. So this material will be applying pressure on the wall and try to destabilize the wall, which may cause bending. Now, what can happen due to the pressure, due to the forces of applied by the retained mass? And if your retaining wall is not of a particular or required strength, then it may bend, it may overturn, or it may slide from its position. So it can slide from its position and move away from the backfill. So that will be the failure of the retaining wall. So then its purpose of retaining the material, retaining the earth will not be achievable. So next point is retaining wall are mostly used for roads, and we are daily we see when we travel across the road in the mountainous region. That means there are walls which are retaining the hilly area behind it. That means hills. Retaining wall. If you talk about the swimming pool, then that water in the swimming pool is retained by the surrounding walls. So then that wall will also act as a retaining wall. At the end of the bridge, in the form of abutment, this is clearly visible various bridges, that there are retaining walls which that means that abutment is basically retaining the material. Constructing a building on a site where filling is required and underground water tank. So when we are talking about the retaining wall is a general term that does not mean it only retain the soil, it only retain the sandy material or hilly area. It can retain any material. It may be water also, it may be sand, etc. Now, if you see in this picture, very much visible, that means you will find this is the retaining wall, which is retaining the material, retaining the soil behind it. And due to the excessive pressure of this material, what you will find that this wall has moved away from its actual position and the failure take place. Now, this is known as sliding. This was the actual position of the wall, and and this is the earth fill. That means a lateral pressure is acting on the wall and wall getting moved away from its position and the failure takes place. So this type of failure, retaining wall, is known as sliding failure. That means sliding means wall just slide away from its original position. So type of failure of retaining wall, this is the one type of failure. Sliding failure of retaining wall. So that means retaining wall, R wall means a retaining wall. So it slides away. Retaining wall slides away from retained earth and fail due to excessive earth pressure. So that means it is very much clear when we have to design, we have to construct the retaining wall, we have to keep in mind how much is the pressure of the retained material is acting on the wall so that we can design the wall against the sliding effect so that it can bear the stresses, the pressure acting on the wall. So retained wall is to be designed for stability against sliding. So this is the one of the parameter when we design the wall. So that means we have to design the wall in such a way that it remains stable against slide. That means it should not slide away from the material. Otherwise, it will get failed. So these are the parameters we will consider during the design, that how we make it stable. Now, pressure due to retained earth should be carefully calculated. If there is a wrong calculation, if you have not taken the material, type of material, height of material, and you can say water table, whether material is saturated, whether material is dry. If the material is currently dry, is it possible that in future there may be water, flow of water, and etc. So all these things you have to take into consideration. So pressure due to retained earth should be calculated carefully. Retaining wall should have sufficient interlocking with the soil. Definitely, if there is no bonding between the foundation of the retaining wall or the soil below the retaining wall and between the retaining wall, that means this surface of the retaining wall as well the soil or whatever be below the retaining wall, if there is not interlocking or there is no friction like that, so then it will definitely move away from the retained material. It will move away and sliding failure take place, which you can easily see in the picture, that is some roadway pictures, roadside pictures we have taken. Now, if you see in this second diagram, now this is a wall, maybe it is from concrete blocks prepared from concrete blocks. So you will just find that this retaining wall is supporting the material, backfill, etc. Now, this retaining wall, after some time, this retaining wall is not vertical. So now it is not vertical. So that means what happened? Basically, this retaining wall has turned. Now, if you see now this picture, if this is a retaining wall, so retaining wall backfill is behind this. This side is backfill. If you need, I can point out. Okay. So this is the backfill basically, and this is retaining wall. This is toe area, just like a human being, just like a leg and foot of a human being. This is a leg and this is foot. So one end will be the toe and other end will be the heel. So what you will observe that this earthfill is applying pressure, and due to that pressure, due to center of gravity, etc. So what is happening? This retaining wall is getting some movement from the earthfill. So when a movement is acting on, if this retaining wall is not suitably placed, then it can turn. It can turn around. So you will see that this retaining wall is getting turned. So it is a self-explanatory picture. That means type of the failure of the retaining wall. Overturning failure of retaining. So this we will call it as overturning of retaining wall, overturning failure, and it will overturn. Now, overturning failure of retaining walls is the rotation of the wall. Now, it is clearly, you can clearly understand it is the rotation of the wall about its toe. Now, this is toe. About toe, it is rotating, not about heel. It is about toe. This will be heel, this will be toe, and this will be stem. Later on, we will discuss in detail. Due to the exceeding movement. Now, what is happening? If you see here clearly, this is the backfill, total backfill. So, backfill is applying pressure in this direction. And here is some material on the toe side. So, it will be applying some pressure or some gravity force here, and weight of these portion is acting here. So, if you take uh, toe point as a point about which movement can take place. So if you calculate movement about toe, then these forces will be applying clockwise movement, and some these forces will be applying anti-clockwise movement, and this pressure due to the material or soil above the toe level, so it will apply anti-clockwise movement or clockwise movement. So that means we have to take into consideration. So what we are saying here, that means if or the toe, the exceeding moment caused by overturning forces. Now, some of the forces are creating movement on the or applying movement on the retaining wall, which can overturn it in comparison to the resisting forces. So, these forces are the resisting forces, and these forces are the overturning forces. Now, it is very much clear if the overturning moment is greater than resisting moment, your wall will not be stable, it will slide, it will rotate. So this type of actual site, it will rotate. So that means we have to take care into consideration while designing. That means how much movement is rotating it and how much movement is resisting it. So definitely resisting movement and the rotating movement, they may be equal, or resisting movement comparatively higher. Now, so retaining wall is to be designed for stability against rotation. In the last slide, we have discussed stability against sliding. Now, another point is stability against rotation. So, overturning forces, yes, I already explained overturning forces due to the earth backfill or retained material. Resisting forces due to the self weight of the retaining wall, load on the toe, etc. Whatever be the material here, it will be applying gravitational force. That means it will be pressing the toe area, and also some earth pressure in towards the retained material. So we have that means summation of MR. Summation means sum of the moments. Sum of the moments of that means sum of the resisting moment. About toe, already told you that we will take into consideration point toe. So sum of resisting moment about toe. M naught is sum of the overturning moment about toe. So overturning of a retaining wall will happen if sum of the moment or resisting is less than sum of the moment overturning. So it will be during design, we will check it, we will apply the corrections, etc., whatever we required. So our design should be such that the retaining wall is stable against sliding as well as rotation. Okay, so let us continue. So that means when you are designing the retaining wall, you have to take care about the sliding effect as well as overturn. So next is type of retaining wall. So today we will discuss one type of retaining wall, and later on we will discuss different type of retaining wall, and then we will discuss the designing part of the retaining wall. Now, very simplest type of retaining wall is the gravity retaining wall. So from title, that means from name of the retaining wall, is clearly mentioned. It is clearly you can understand that major effect is of the gravity, that means weight of the retaining wall. Now, if you see here this wall is a retaining wall, and the backfill is there. And this side is toe side, this side is heel side. Now, even backfill is surcharged backfill with some angle 30 degree. So, additional which we have discussed in soil. And from this side, if I show is by an arrow, so this is toe side, it will be resisting, and this side it will be applying pressure, and this one hole is to drain out the water if there is water, so that it should not apply pressure. So this is stem, and this is toe, and this one is heel. So this is the part of the retaining wall. And the schematic diagram will be like this. This is the retained material. So that retained material, this material is shown like this. This is the retaining wall. It may be vertical or it may be inclined. So in this case, for in upper photograph, it is vertical, and in this second photograph, it is just a slant. So this is toe, heel, and this is material above the toe. That means it is applying pressure to register its movement, and this back will applying pressure which due to the retained material. So retaining, what is gravity retaining? Well, it retained backfill due to its own weight. Now, this is very important picture. This is a you can say concrete retaining wall, and you may observe here we have taken slant side in this side. Here it may be. It is your choice. Now, if you see one by one, we can discuss. Now, this is active thrust. This is the backfill. This is the backfill total. So it is applying active thrust. You well know that active work pressure, passive work pressure. So this is the wall. So we consider this is the weight of the wall acting downward. So one force is acting, in this direction. Another force weight is acting in this direction. This one is your heel. This is toe, and this is the soil which is applying bearing pressure, and even sliding resistance. That means if it is offering a resistance, if this soil is having a good bond with the base of the retaining wall, then there may be some resistance. It is offering sliding resistance, passive pressure. So you will observe one by one there are various type of forces. Not this force, this force. That means this is the pressure, and this is third force, sliding force. This is bearing force. Okay, so this will be active pressure. This is open to sky. This is free. So when you want to take movement of all the forces about the toe point, so then this pressure, this weight, this sliding resistance, bearing forces, passive resistance, etc., etc. So from this you can easily calculate, that means whether this wall is stable against sliding as well as against rotation. Mathematically